You know, a few years back, there was that Mars mission that went like way over budget.
Yeah.
It really made everyone realize just how expensive it is to get anything to Mars.
Oh, for sure.
But what if there was a cheaper way, like maybe some sort of ride sharing, but for space?
Interesting.
Well, the European Space Agency, they think they may have actually figured it out with this new LightShip concept.
Yeah, it's really exciting. And it's not just about saving money.
Right.
LightShip is really going to completely change how we approach going to Mars.
Like how so?
Well, it's kind of like, I think about it this way. Instead of building a mansion every time you want to go to Mars, we're creating like a modular house.
Okay.
It's more efficient, way more adaptable, and like way more accessible.
So instead of launching these mega expensive missions every 10 years or something like that,
Yeah.
we could be doing smaller missions all the time.
Yeah, exactly. Multiple smaller missions running all the time.
And that would...
And that opens up a whole world of possibilities.
Yeah, like what...
Well, think about it.
Yeah.
You know, universities, private companies, even countries with like smaller space programs could all get in on the action.
Oh, wow.
It's not just for like the big guys anymore.
So it's like really opening it up.
Yeah.
Okay, I'm intrigued. I'm definitely intrigued.
Okay.
But how does this space ride sharing actually work?
Okay.
Does LightShip literally tow stuff across the solar system?
It's not really towing. It's more like a ferry service, I guess you could say.
Okay.
LightShip, it acts as a transport system, and it carries smaller spacecraft all the way to Mars orbit. It's a two-part solution, and it solves the two biggest headaches we have when we're trying to explore Mars.
Which are...
Propulsion and communication.
Okay, let's break that down.
Okay.
First, the propulsion issue. How do they get enough fuel for such a ridiculously long trip?
Yeah, so that's where it gets really cool.
Okay.
They're looking at a combination of things like solar electric propulsion,
Okay.
which uses the sun's energy, and they're even considering maybe nuclear electric propulsion.
Nuclear... Wow.
Yeah.
That's a whole other level.
It is.
I'm picturing something straight out of Star Trek.
Yeah, well, not quite warp drive just yet, but
Right.
it is a really significant leap forward in terms of how efficient we can be.
Okay.
Think about it this way. Instead of relying on those big, bulky chemical rockets,
Right.
we're using a compact, long-lasting power source.
Right.
Basically, they can go a lot further on a single tank.
Okay. Yeah, that makes sense.
Yeah.
So what about once they reach Mars and they're orbiting, how do these smaller spacecraft stay in contact with Earth?
Okay, well, that's where the second part of the solution comes in.
Okay.
It's called MARCONI,
MARCONI.
which stands for Mars Communication and Navigation Infrastructure.
Oh, wow.
Essentially, it's a dedicated communication hub
Okay.
on board LightShip, and it acts as a relay between Earth and all those little spacecraft circling Mars.
So it's like having a dedicated interplanetary internet connection.
You got it.
Wow.
And that's crucial for any Mars mission. You know, we need a steady stream of data flowing back and forth, both for scientific analysis and just to make sure everything is running smoothly.
So we've got the transportation covered, we've got the communication covered. What about the passengers themselves?
Okay.
What kind of spacecraft are we talking about?
So right now, the ESA is working with 4 different groups to actually create blueprints for these like compact, affordable Mars satellites. And these teams, they're really interesting. They come from a bunch of different organizations.
Oh, like what?
You've got your established companies like Argotec and Deimos Space.
Okay.
You even have university research groups like the team from Politecnico di Milano with SITAEL.
Wow, so it's a real mix.
It is.
And they're all working together on this.
They are, yeah. And there's even an American company involved called Redwire.
Wow, 4 different teams. That's a pretty big collaborative effort.
It is a huge collaborative effort.
Yeah.
And what's really interesting is that they're not designing these satellites for any particular mission yet.
Oh, really? So what are they doing?
So instead, they're focused on creating like a really versatile platform that can be customized later on.
So it's like building a super adaptable base model
Yeah.
of a Mars spacecraft, and then you can outfit it with like different instruments and tech depending on the mission.
Yeah, it's a really brilliant approach.
Yeah.
Makes the whole system incredibly flexible, and it's so cost effective.
It's like building a Martian Swiss Army knife.
Exactly.
I like it.
Yeah, and this whole focus on collaboration, it's not just ESA member states.
Right.
They're really encouraging international partnerships too.
Oh, that's great.
Yeah, it aligns with this global desire to make space exploration more inclusive.
I like that.
Yeah, it's great.
Okay, so I'm sold on the concept. I'm sold.
Good.
But how does this all tie into ESA's long-term plans for Mars? I remember hearing about this thing called Explore 2040.
Yeah. So Explore 2040 is all about, laying the groundwork for future human missions to Mars.
Okay.
And LightShip is really like central to that vision. Yeah, in fact, they've already started planning for the first LightShip mission.
Really?
It's going to be called LightShip 1.
Okay, so it's not just an idea. They're actually building this thing.
Oh, yeah. They're building it.
Yeah.
And the information they get from these small satellite studies, it's going to directly inform how they design LightShip.
So when can we expect to see this thing in action?
Well, they're planning to really dive deep into full mission concepts in 2026.
Okay.
And they'll be using these smaller platforms as potential passengers.
Okay.
So this means, nailing down what the scientific goals are, figuring out the right instruments.
Yeah.
Essentially mapping out what each of these missions will actually look like.
It's all coming together.
Yeah, it is.
This is so exciting.
I know.
But it feels like this LightShip technology, it could have implications beyond just Mars.
Oh, you're absolutely right.
Right.
While the initial focus is on Mars, the ESA is already exploring how LightShip could be used for missions to the moon asteroids.
Wow.
Even further destinations.
So we could be looking at like a whole new era of space exploration.
Yeah.
With more frequent and affordable missions to all kinds of places.
It's pretty incredible.
It's like somebody is building a cosmic highway system, and LightShip is the key.
You got it. And it really highlights the potential. LightShip has to revolutionize how we access space.
It really does.
Yeah.
Okay, this is mind-blowing. This is absolutely mind-blowing. We've covered so much here, from like the struggles of traditional Mars missions to this like groundbreaking new LightShip concept.
Yeah, for sure.
But before we get carried away, let's just make sure we're all on the same page.
Yep.
What are the key takeaways so far?
Let's recap.
So we know that LightShip is going to make these missions cheaper and we can do them more often.
Right.
But how does that actually change like the kind of science we can do on Mars?
It's like think of it this way. You know how you use a magnifying glass to see something up close?
Yeah.
Well, it's like going from having one powerful magnifying glass to having a whole bunch of different microscopes, each one with like a different lens.
I like that. Okay.
So instead of just one mission trying to do it all, we can have multiple specialized missions happening at the same time.
Oh, okay.
Running concurrently.
So instead of one giant rover kind of lumbering around for years, we could have a whole fleet of smaller, more nimble robots.
Exactly.
Each one with its own specific purpose.
Yeah, you got it. One could be like analyzing soil samples for signs of life.
Right.
Another one could be mapping the Martian subsurface, looking for water ice.
Oh, that's cool.
We could even have some that are just dedicated to studying the weather patterns on Mars or like volcanic activity.
So basically, more missions means more data, which means we understand Mars better.
Exactly. It's a much richer understanding of the planet as a whole.
I like it.
Yeah.
But how does all this tie into like the bigger picture of ESA's Explore 2040 spring energy?
Okay.
Especially when it comes to human missions.
So Explore 2040 is essentially a roadmap for how we're going to establish a sustainable human presence on Mars. And LightShip is like the logistics company that makes it all happen.
Logistics company.
Yeah, think about it like you're trying to build a city on Mars.
Okay.
You need like a constant supply of stuff, building materials, supplies, equipment.
Makes sense.
And that's where LightShip comes in.
So LightShip will be responsible for transporting everything.
Yeah, pretty much.
That's needed to build a Martian base camp.
Exactly. It's like the ultimate interplanetary moving company.
I like it.
And it's not just about like the physical stuff.
Right.
The data that we get from these frequent robotic missions powered by LightShip tells us so much about the Martian environment, like potential hazards, resource availability.
Right. That's important.
Yeah. It's essential for making sure that any future human explorers are going to be safe.
It's like sending an advanced team to scout things out before the main group arrives.
Yeah, exactly. Like a scouting party. They go and set up a base camp, survey the terrain.
Exactly.
And then the main expedition can follow.
I like that analogy.
Each successful LightShip mission, it teaches us a little bit more about Mars.
Makes sense.
And it gets us closer to actually sending humans.
So it's like baby steps.
Exactly. It's a gradual, sustainable approach.
Okay.
And that's a key part of Explore 2040.
It's like learning to walk before you run.
Yeah, we're not just rushing in blindly.
Yeah.
We're taking our time, learning as much as we can, and building a solid foundation for the future.
So speaking of collaboration and global efforts, how does LightShip actually encourage international partnerships?
Well, just the way LightShip is designed,
it
just promotes collaboration.
Okay.
You imagine this, okay?
Yeah.
A single LightShip mission.
Okay.
But it's carrying payloads from different countries.
Okay.
And each country is contributing their own unique expertise and instruments.
Oh, I see.
So you could have like European technology working alongside American instruments.
Okay.
Maybe even with contributions from Japan or Canada.
It's like a global scientific potluck.
Exactly. Everyone's bringing their best dish to the table.
I love it.
And that's what the ESA is really aiming for.
Right.
They see LightShip as a way to bring together the best minds from around the world.
Yeah.
And really pool resources and knowledge to advance our understanding of Mars.
Yeah.
It's a pretty inspiring vision.
It is.
Yeah.
It really speaks to that human need to explore and discover as like one species.
It does.
Okay, so we've talked a lot about Mars.
Yeah.
But I know that you mentioned that LightShip could also be used for missions beyond just the Red Planet.
Right.
So what other destinations could this technology open up for us?
Well, Mars is the main focus right now.
Right.
But the potential applications for LightShip are huge.
Okay.
Because it's so adaptable.
Yeah.
And the propulsion system is so efficient, it makes it perfect for missions to all kinds of celestial bodies.
Like, give me an example.
Well, think about the moon.
Okay, the moon. Yeah, what kind of missions could we do there?
Well, we could use it to build a permanent lunar base.
Okay.
And LightShip could transport equipment supplies, even personnel, to and from the surface.
Wow.
We could also use LightShip to deliver like scientific payloads.
Oh, okay.
To very specific locations on the moon.
So we're not talking about just like short visits.
Right.
We're talking about like a sustained presence.
Exactly. Long-term research, maybe even using lunar resources.
Wow, that would be incredible.
It would, and that's just the moon.
Right.
We could also use LightShip to explore asteroids.
Oh, yeah.
Which are like time capsules from the early solar system.
That's cool.
Yeah. Those missions could teach us so much about how our solar system formed.
Yeah.
And we might even find resources out there that could be really valuable.
Oh, wow.
For future space exploration.
So with LightShip, we're not just talking about like visiting these places.
Yeah.
We're talking about like really being there, establishing a presence, doing some serious research, and maybe even using resources we find out there.
That's right. It's like opening up the solar system for business.
I like it.
It's a really exciting idea.
Okay, I want to shift gears a little bit and talk about the nitty-gritty of how LightShip actually works.
Okay.
We've talked about the concept.
Right.
But I want to know more about like the technical details, especially the propulsion system.
Okay.
You mentioned solar electric and nuclear electric propulsion.
Yeah.
How do those actually work, and what are the advantages of each one?
So let's start with solar electric propulsion.
Okay.
Basically what it does is it harnesses energy from sunlight.
Right.
And it uses that to create electricity, which then powers an ion engine.
It's like a super efficient solar panel powering a super futuristic engine?
Exactly.
Okay, I've heard of ion engines. They use electricity to like accelerate ions, and that creates thrust.
Yeah.
But how is that more efficient than using the traditional chemical rockets that we've been using forever?
So ion engines, they expel ions at incredibly high speeds.
Okay.
Which generates thrust. But the amount of thrust is actually pretty small compared to chemical rockets.
Oh, okay.
But the key is that they are super efficient and they can maintain that thrust for a really long time.
Okay, so they don't need as much fuel.
Exactly. They need far less fuel.
So it's like the tortoise and the hare.
You got it.
The ion engine may be slow and steady, but it wins the race in the end.
Exactly, because it's so fuel efficient.
I like it.
Now let's talk about nuclear electric propulsion.
Okay.
This technology, it uses a nuclear reactor to generate electricity.
Okay.
And similar to solar electric propulsion, it uses that electricity to power an ion engine.
Okay, so I have to admit, the idea of a nuclear reactor in space is a little bit scary.
I can understand that.
Are we talking about like a mini power plant flying through space?
Not quite.
Okay.
It's a highly specialized and very rigorously tested system.
Okay.
They're looking at using something called a radioisotope thermoelectric generator.
Okay, what is that?
It's also called an RTG.
RTG, okay.
It's essentially a nuclear battery.
A nuclear battery?
Yeah, and what it does is it converts the heat from the decay of a radioactive isotope.
Okay.
Usually plutonium-238.
Okay.
And it turns that into electricity.
So it's not like those big nuclear reactors we use here on Earth?
No, not at all. It's a much more controlled release of heat energy from this radioactive material.
Okay, so then that heat is converted into electricity.
Right.
Which powers the spacecraft.
Exactly. And it's ion engine.
So what are the advantages of using nuclear over solar for a mission like LightShip?
Well, one of the biggest advantages is that you're not dependent on the sun.
Right, because the solar obviously needs the sun.
Exactly. And that can be a problem if you're traveling far away from the sun.
Right.
Or you're in like a shadowed region.
Yeah, that makes sense.
The nuclear electric propulsion, it gives you a continuous and reliable power source.
Okay.
No matter where you are.
So it's like a backup generator for your spacecraft.
Yep, exactly.
Even if you're in the shadow of a planet.
Yep, you still have power.
That's really cool.
And that makes nuclear electric propulsion really appealing for missions to the outer solar system.
Right.
Or places where there's not a lot of sunlight.
Okay, so for a long mission like LightShip, where you have to go really far, maybe operate in different environments, the nuclear makes sense.
Absolutely. It gives you the flexibility to explore more challenging destinations.
And you know that it's going to work.
Yeah, exactly.
This is fascinating stuff.
I know.
But I want to switch gears again and talk about the communication part of LightShip.
Okay.
So we talked about MARCONI.
Yeah.
The communication system on board. But how does it actually work?
Well, MARCONI, it's basically like a really powerful radio relay station.
Okay.
It uses a network of antennas to transmit and receive radio waves.
But how do radio waves travel through space?
Okay, so that's a common misconception.
Okay.
Radio waves, they're like light.
Okay.
They're a form of electromagnetic radiation.
Okay.
And they can travel through the vacuum of space with no problem.
They don't need air?
They don't need a medium like air to propagate.
Yeah. Okay, I always thought they did.
Nope. And that's how we talk to all of our spacecraft, from the International Space Station to, like, Voyager way out there.
That's incredible.
So MARCONI sends out these really powerful radio waves that are carrying data from the spacecraft orbiting Mars.
Okay.
And those waves travel at the speed of light back to Earth.
Okay.
Where they're picked up by giant antennas.
And then the whole thing works in reverse.
It does, yeah.
So we can send signals back to LightShip.
Exactly. We can send commands instructions.
It's amazing that we can talk to something millions of kilometers away as if it was right next to us.
It is pretty amazing.
But I'm sure it's not without its challenges.
You're right about that there are some challenges.
Like what?
One of the biggest challenges is the time delay.
What do you mean?
Well, because the signals are traveling at the speed of light, which is super fast.
Right.
But it's not instantaneous.
Right.
It still takes time for them to get there.
So how long does it take for a signal to travel from Mars to Earth?
Well, it depends on where the planets are in relation to each other. But on average, it's about 10 minutes for a one-way trip.
10 minutes?
Yeah.
So if you send a command to a spacecraft, it takes 10 minutes to get there, and then another 10 minutes to hear back that it was done.
Exactly.
Wow.
This time delay, it makes things really challenging for mission control.
Right.
Especially if there's like a time-sensitive situation or something unexpected happens.
I can imagine.
It's kind of like playing a video game with a really laggy internet connection.
That's a good analogy.
Yeah, it requires a lot of careful planning, and you have to be able to anticipate what might happen.
Right.
And you need systems that can handle communication disruptions.
Right, because it's going to happen.
Yeah, it's unavoidable.
So it's not just about sending and receiving signals, it's about managing all those challenges.
It is.
Of communicating over these vast distances.
Exactly. And making sure that information flow is reliable and effective, even with those time delays.
Okay, let's talk more about those 4 groups that are working on those small Mars satellites.
Yeah.
The ones that are going to be hitching a ride on LightShip.
Right.
We've talked about the modular design and the scientific stuff they could do. But what are some of the challenges they face trying to build spacecraft that are both small and capable?
So designing any spacecraft for deep space is already really hard.
Yeah.
But then when you add in the fact that it has to be small, it becomes even more challenging.
Right, so you're trying to pack all the features of like a really fancy car into a tiny little compact car.
Exactly.
Yeah.
These teams, they have to figure out how to miniaturize all the essential components.
Like what kind of component?
Like power systems, communication systems, scientific instruments.
Right.
And they have to make sure that all of that is tough enough to survive space travel.
Right, because space is not exactly a friendly place.
It's not. You've got extreme temperatures, radiation, micrometeoroids.
It's a lot to handle for any spacecraft.
It is. And that's why these groups are like pioneers in spacecraft miniaturization. They're using cutting-edge materials, advanced manufacturing techniques, some really ingenious design strategies to pack as much as they can into a tiny little package.
So they're not just shrinking existing technology. They're inventing completely new ways to design spacecraft.
Exactly. They're pushing the boundaries of what's possible, always trying to make things smaller, lighter, and more efficient.
It's like they're building Martian smartphones.
Yeah, that's a good way to think about it.
All that computing power in these tiny devices.
Yeah, and the implications of this are huge.
Yeah, how so?
By making spacecraft smaller and cheaper, we can open up space exploration to way more people.
Right.
And we can do missions more often.
So it's really democratizing access to space.
Exactly.
Yeah.
Making it possible for more countries, universities, even private companies to get involved in this incredible journey of discovery.
Okay, so we've talked about the vision of LightShip, we've talked about propulsion communication, even how they're making these spacecraft smaller. But before we move on, let's just recap the key takeaways so far.
Okay, let's do that.
So we've talked about like all the amazing tech behind LightShip and how it could like open up the solar system for us.
Yeah.
We even touched on how challenging it is to build these tiny spacecraft.
Right.
But what's the timeline for all this? Like, when can we expect to see these LightShip missions actually happening?
Well, as we said earlier, they're already planning LightShip 1.
Right.
But to really understand the big picture, you have to look at ESA's Explore 2040 strategy.
Okay.
It basically lays out a step-by-step approach for exploring Mars.
Okay.
And LightShip is like a key part of every single step.
So it's not just like a one-and-done kind of thing?
No, not at all.
Okay.
It's a long-term plan with lots of different stages.
Right.
Each stage builds on what they learned from the one before.
So the first phase is all about robotic exploration,
Right.
using LightShip to deliver these increasingly complex missions to Mars.
Exactly. It's like a gradual ramp-up. They'll start with smaller payloads and like simpler objectives. And then over time, they'll expand the scope and complexity of the missions.
So we might start with missions that are just focused on collecting specific data, like analyzing soil samples or mapping geological formations.
Yes, and then as the technology gets better,
right,
and we learn more about Mars,
yeah,
we can move on to more ambitious missions.
Like what?
Maybe deploying rovers or drilling platforms even. Each successful mission, it gives us valuable data and experience.
Right.
And it paves the way for tougher scientific goals.
So the ultimate goal here is still to send humans to Mars, right?
Absolutely. That's the holy grail of Mars exploration.
Yeah, it's the dream.
It is.
But that's got to be a long way off, right?
It is. It's a huge undertaking.
Yeah, I mean, we're talking about sending people millions of kilometers away, keeping them safe, giving them air to breathe, dealing with like all the psychological effects of deep space travel.
It's a whole other level of complexity.
Yeah, for sure.
But Explore 2040 and LightShip are all about making that happen eventually. It's like building a house.
Okay.
You need a solid foundation before you can do anything else.
So all these robotic missions, all the data they gather,
right,
it's like laying the foundation for a future Martian colony.
Exactly. Each successful mission, it adds another brick to that foundation.
It's pretty exciting to think about what that future might look like.
It is.
You know, humans living on Mars, doing research, exploring the planet, maybe even building a self-sustaining colony.
It does sound like science fiction.
It does.
So with technologies like LightShip, it's starting to feel more and more real.
Yeah, I agree.
It's amazing what humans can do.
Yeah.
You know, our drive to explore is just incredible.
It really is. So who knows? Maybe one day we'll be talking about Martian outposts, interplanetary trade, even space tourism.
It's mind-boggling when you think about the possibilities.
It really is. Okay, so I'm totally on board with this whole LightShip vision.
Good.
But what about those big flagship missions to Mars?
Yeah.
Like Curiosity and Perseverance.
Right.
Are those going away?
No, they're not going anywhere. They still have an important role.
Okay.
But their focus is different.
Okay.
Think of them like the pioneers, the trailblazers. They make the big breakthroughs.
Right.
They push the limits of what we know, and they pave the way for more focused exploration.
So the big missions make the headlines with these groundbreaking discoveries.
All right.
And the smaller LightShip missions, they kind of do the follow-up work.
Exactly. They gather more data, fill in the gaps, and build a more complete picture of Mars.
So LightShip is the key to finding that balance, using both approaches to create a better Mars exploration program.
Exactly. It's about making the most of what we have, you know, all our resources and our expertise.
Right.
And ensuring that every mission, big or small, helps us understand Mars and prepares us for future exploration.
Well, I think we've covered pretty much everything here.
Yeah, I think so.
About LightShip and what the future of Mars exploration might look like.
It's been a great discussion.
It has. We've gone from the technical stuff to the big dream of humans on Mars.
Yeah, for sure.
And I have to say, I'm super optimistic about what the future holds for space exploration.
I am too. We're at the beginning of a new era.
Yeah.
Driven by incredible technologies like LightShip.
Right.
We've got amazing international collaborations happening.
Yeah.
And just this renewed excitement for space.
It's a great time to be alive.
It really is.
Especially if you're a space enthusiast.
Absolutely.
So to all our listeners out there, thank you for joining us on this incredible journey into the future of space exploration.
Yeah, thanks for listening.
We hope you found it as inspiring and thought-provoking as we did.
Keep looking up at the stars. Keep asking questions and never lose that sense of wonder.
I love that.
Who knows? Maybe one day you'll be one of the explorers going to Mars or even further.
And on that note, we'll sign off.
Sounds good.
This has been The Deep Dive, and we'll catch you next time for another amazing exploration of the universe and beyond.